In this lesson, we are going to be modeling linear relationships, which basically means we're going to be looking at some scenarios from the real world. We're going to be writing an equation for it, and then we're going to be graphing it. And we're going to do that using our method of graphing by finding the X and Y-intercepts and graphing that way. So let's see what this looks like. Baker sells bread for $3 a loaf and rolls for $1 each. The baker needs to sell $24 worth of baked goods by the end of the day. So what we're going to do is we're going to first think about what equation describes that problem. We're going to graph it by finding the X and Y-intercepts. And we're going to use the graph to approximate how many loaves of bread the baker must sell if 12 rolls are sold. Okay, so first let's think about how we would like to label our axis. We always look for the independent and dependent variables. So we have two variables. We have bread and we have, we have bread that are loaves of bread and we have rolls of bread. Now there are instances where one of them is really not dependent on the other. Here you have two items that you're selling. One of them is neither really dependent on the other. So you just have to make a decision about which is which. So what we're going to do is we're going to say that the loaves of bread are going to be on the x-axis and the rolls are going to be on the y-axis. So as we write our equation, we're going to think about that. The baker needs to sell $3 a loaf, and since x is our variable that we decided to represent loaves, that would be 3x. 3 times the number of loaves. And rolls for $1 each, and we have decided that the y is going to represent the rolls, so that would be plus 1y, and the y can be invisible. The baker needs to sell $24 worth by the end of the day, so all together he needs to sell $24. So this represents $3 per loaf, $1 per rolls, and then the $24 all together. So that's how we wrote our equation. Next, we're going to label our axes. We decided the number of loaves will be on the x-axis, and the number of rolls will be on the y-axis. Next, we need to graph it. So to graph it, we're going to find our x and y-intercept. Remember, to find the y-intercept, we're going to plug 0 into x, and when we plug 0 into x, this essentially goes away, and y is just equal to 24. So we go over to the graph, and we're going to put a point on 24. Next, we're going to find the x-intercept. We find the x-intercept by plugging in 0 to y. So it looks like this, and this term goes away. So that would be 3x equals 24. So the x-intercept would be 8. So we found our 2 points that we needed. Now we can graph it. Now, by using the graph, this is why it's important to use a straight edge when you're graphing, because you want a really straight line. Use the graph to approximate how many loaves of bread the baker must sell if 12 rolls are sold. So here's 12 for the number of rolls, and you go across the graph right there. And when you look at it, it crosses right there at how much? It looks like that there would be 4 rolls. So that's why your graph needs to be as accurate as possible so that you can use your graph to do the estimating. Of course, you could do that mathematically, but we're trying to do it by using the graph. All right, let's try again. This time we have a local charity is selling seats to a baseball game. Seats cost $20 each, and snacks cost an additional $5 each. The charity needs to raise $400 to consider this event a success. Well, again, we have two things. We have the cost of seats, and we have the cost of snacks. Neither one of them is really dependent on the other, so we can decide how we want to do it. We are going to put the number of seats on the x-axis because they mentioned it first. X right there. And we're going to put y for the snacks. Now let's write a linear equation. They are selling seats cost $20 each. $20 times the number of seats. Snacks cost an additional $5 each. So we're going to add that to $5 times the number of snacks. The charity needs to raise $400 to consider this a successful event, so that all equals $400. So there's how we wrote our equation. Next, we want to graph it. So here's our equation. We're going to label our axes the way we mentioned, the seats on the x-axis and the snacks on the y-axis. We're going to graph it by finding the x and y-intercepts. To find the y-intercept, we plug in 0 to x, and that term goes away. We're left with 5y equals 400. So y is equal to 80 because we just divide by 5. So we go over to the y-axis and we do 80. Find the x-axis. We plug in 0 to y this time. That term goes away. Now we have 20x equals 400, so x will be equal to 20 after dividing both sides by 20. So we go to the x-axis and we plot 20. We take a very straight edge, protractor, ruler, draw our line. Use the graph to approximate how many snacks the charity must sell if 10 seats are sold. Here's the number of seats. We go to the number 10. We look up and see where it crosses the graph. And that would be 40 seats. Now what would happen if when reading these scenarios you reversed and you put the wrong one on the x-axis and the wrong one on the y-axis? Well, you're still going to, the graph is going to look different, of course, but you're still going to get the same answer. So these are scenarios where both variables are really not independent or dependent on each. In today's paper, you will find that yours are already labeled for you. So look at the labels so that you'll know what is x and what is y. Good luck.